Okay, so now we got 5, 2. Now we're going to talk about logarithms. You might have seen this in science class, like especially chemistry, or maybe not. But logarithms are just exponents. So down here, number 4, I'm going to write down they are just exponents. So if I look back at number 1, it's a log equation. I can actually write that in exponential form. This little number down here, that's always your base. So b is the base. And then this number right here is going to be the exponent. So n is the exponent. And then it's equal to the m, which is the argument. Okay, there are some conditions. So let's talk about the base first. The base must be greater than 0. However, the base is never equal to 1. And then the argument, which is m, must always be greater than 0. And we'll talk about that more later on. Okay, so I'm going to first of all change, let's do these first. I'm going to change both of these to exponential form. So to do that, this is my base, that's my exponent, and that's what it's equal to. So 9 to the 1/2 equals 3. Okay, number 8, this is my base, this is my exponent, and that's what it's equal to. So 5 to the -1st equals 1/5. Okay, now let's do the opposite. Now let's change them from exponential form to log form. So if I want log form, I want a log. This number is the base. And these two numbers just switch places. So 164 equals -2. Over here, log, my base again is 8. And these two numbers switch places. So 2 equals 1/3. Okay, now there might be a time where a log does not have a base, like these two. I don't see a little number there. If that's the case, the base is always 10. So I'm going to put a 10 in here. Okay, and now I'm going to rewrite this. I'm going to change these to exponential form. This is my base, that's my exponent, and this is what it's equal to. On this one, this is my base, this is my exponent, and that's what it's equal to. Okay, let's move on. All right, so it looks like the directions say to first of all change them to exponential form, and then you're going to evaluate, which means you're going to solve. Okay. Now this time it doesn't have an equal sign. So that just means they're all equal to, we don't know. We got to find it. For example, we have that. So if I was to rewrite that, it would be 2 to what power equals 16. Well, this is where you'd look at that blue sheet that I gave you and figure out 2 to what number is 16. The answer is 4. 14. I'm trying to figure out 3 to what number is 27. If you look at your blue sheet, 3 is going to be the answer. Okay, 16. If I don't have a base, there's really a 10 there. And I don't know what it's equal to, so we're going to say it's x. So this would be 10 to what power is 1,000,000. Well, since I have 6 zeros, 10 to the 6th power is 1,000,000. Okay, number 18. This means 7 to what power is 7? That would be 1. Number 20. 2 to what power is 8? Again, you're getting all these answers from your blue paper. So 2 to the 3rd power is 8. Okay, the next one. Again, I don't know what it's equal to, so I'm going to say it's x. So 6 to what power is 216 If you look at your blue paper, it should say 6 to the third power is 216, so your answer is 3. Okay, those are the easy ones. Okay, so I'm going to cross off 13, and I'm going to cross off, that's it. Okay, so number 15, this is like saying 125 to what power is 5. If your base is bigger than your argument, your exponent's going to be a fraction. So first you want to look to see 5 to what power is 125. Well, that's going to be to the third power. So since 5 to the third power is 125 to the reciprocal power, which is 1/3, is 5. So if this base is bigger than this, your exponent is a fraction. Okay, so we said at the beginning that your argument, which is this number right here, must be greater than 0. And since it's not, your answer is no solution. Okay, the next one. This is like saying 6 to what power is 1. Any number to the 0 power is 1, so your answer is 0. Okay, number 21. This is like saying 7 to what power is 1/49. Well, this time my argument is a fraction. So if I have a negative exponent, that means I'm going to have a fraction. Since 7 squared is 49, 7 to the negative second power is 1/49. And finally 23. 81 to some power is 9. Well, this one's just like number 15 because the base is bigger than the argument, which means my answer should be a fraction. So I got to figure out 9 to what power is 81, and then whatever that power is, I flip it. So it has to be 1/2. Since 9 squared is 81, 81 to the 1/2 is 9. Okay, last page. So now we're going to talk about natural log, which is weird because you'd think that natural log would be NL, but it's actually LN. The base is always E. That's the number we talked about yesterday. So if I see a natural log, the base has an E there. I'm going to cross off 26 and 28. I'm going to go ahead and do 25 first, I guess. If I'm going to rewrite this in exponential form, it's going to be E to this number, that's my exponent, equals that number. So E to the 3.738 power is about 42. On this one, I want log form. Well, since I have an E as a base, I want to use natural log. My base is E. Now you can put the E there or not. And these two numbers switch places. 1097 is about 7. Okay, so the last section we are going to change to exponential form, and then we're going to evaluate. These are all natural logs, which means my base for all of these are E's. So I'm going to write those in there. Okay, doesn't have a base, so it's really an E. And I don't know what it's equal to, so we're going to say it's equal to X. So the first one, I'm trying to figure out E to what power is 1. Again, it doesn't matter what your base is. Any number to the 0 power is 1. So my answer is 0. Okay, now I didn't really have to do all this because my argument is not greater than 0. So this one is actually no solution. Now these two look a little weird because I have a number in front. I haven't talked about that yet. So before I actually do these two, I need to do 30. I forgot that it goes in this order. That's fine. Okay, this one. This is like saying E to what power is E? Well, there has to be a 1 there because E to the first power is E. So this is 1. So I want you to remember this right here. Always remember this. This is going to help you out tremendously when you go and do the rest of these problems. Okay, let's look at 32. So this would mean e to some power is e to the 7th. Well, since my bases are the same, my exponents have to be the same. So my answer to this one is 7. Okay, so now this causes a problem because I have a number in front. So what I'm going to have to do is move my exponent right here down in front. You're allowed to do that. That's called the power rule. So actually, for these last 4, I'm going to do something called the power rule. So I'm going to drop this down in front. And I don't have to put a little e there. That's irrelevant, really. So if I recall, the natural log of e is 1. So really I'm taking 3 times 4 times 1. So my answer is 12. Okay, this one, I'm going to get rid of these e's. Okay, let's actually do 35 next. So 35, this right here is 1. Negative 2 times 1 is just negative 2. I'm going to do 36 next. There's actually 2 ways you can do this. You can think e to what power is e to the 6th, like I did back up here on 32. But you should see a pattern. The natural log and the e cancels out, and you're just left with whatever the exponent is. And then finally I have this one. I have a fraction. This is the same thing as saying the natural log of e to the negative 3rd. Because if I have a fraction, that means that my original exponent was negative. Well, now it looks like number 32 and 36. So these kind of just go away, and you're left with negative 3. I think that's all for 5-2. Yes. All right. Goodbye.